Hi everyone, welcome to Management 650. It's week 11. This is Helen, and I'm going to review the solution for view and example for problem 6. In problem 6, we determine if a linear model is appropriate for making predictions about two sets of numerical variables. Here's our problem. It says classified ads in a newspaper offered for sale several used cars of the same make. Listed to the left are the ages of the cars and the advertised prices. So let's take a look at our data. Column A, our age variables, those are our X variables, our prediction variables, our independent variables. Column B are our Y variables, those are our response variables or our dependent variables. X predicts Y. Age predicts prices advertised. So we're asked to make a scatter plot for these data. We already know how to create a scatter plot that will appear on the next screen. So let's take a look at our scatter plot, and we're asked, do you think a linear model is appropriate? So let's take a look at our data points. The direction of our data points is from upper left to lower right, and that means it's negative. Our pattern, our formation, is straight. It's relatively straight and it's linear. Now this is very important because when we consider that a simple regression analysis is based on a linear relationship between two variables. If our data are not linear, our prediction may well not be accurate. So this is very, very important. We focus on that. The other thing we look at is the location of the data points, how close they are to each other, and they're relatively close to each other, so we're going to write in that they are fairly strong. So our location is fairly strong. So we asked, do you think a linear model is appropriate? And we're going to say yes. So we've determined we can proceed with our analysis, and we're now asked to find the equation of the regression line. We will be performing a regression analysis in Excel, and then we'll go on and perform a regression analysis in StatCrunch. StatCrunch is actually faster, but I'm going to show you first in Excel. So top of the toolbar, data, data analysis, select regression here, click OK. Now our X range comes first, label prices advertised all the way down. Next is our X variable, X range, label all the way down. You can't quite see that. Check labels, confidence level 95%, output range. I'm going to put the summary in cell C12. Check residuals, standardized residuals, and residual plots. Click OK, and it populates out. Your regression analysis populates out on your screen. So from our summary output, we're going to focus in on these two columns. You see our y-intercept here and our age by year. Coefficients of our y-intercept, 12,139. Coefficient of our age is negative 842. So our regression equation is up on the screen. 12,139 plus negative 842 times age. Again, our slope is negative 842. Our y-intercept, 12,139. What this means is that for every 1 year of age of the car, our price declines by $842. Next, we're asked to check the residuals to see if the assumptions and conditions for inference have been met. Now, the residuals, here we were on our intercept and our age, our slope, come down to your residual output, and it's the third column to the right. It says residuals. You can't see the whole thing, but it's shaded in yellow. So that's what we're going to focus on. Remember, your residuals are observed values. Your Y column here, minus predicted values, and your predicted values actually appear to the left of your residual column. Now, Excel created a scatter plot of the residuals against the X values. You can compare residuals against the X values or residuals against the predicted values. You can do that, as I showed you, where those columns were located on the output. You can do that yourself, but Excel analysis, regression analysis, generated this age residual plot. So we're going to look at our linearity assumption, and we did do that in our original scatter plot when we compared age and prices advertised. We saw a linear formation. When we're looking at our age residual plot, we're looking for no pattern. So basically, we really don't see a pattern here with these data points. There's a little bit here, but basically there's nothing there that would be of concern to us. So we are going to make the determination that our linearity assumption and conditions have been met. Next, we'll look at our independence assumption. We know it's difficult to determine if this is met. We have examined in the past our randomization condition. We have no way of knowing if this data were randomly generated. So we're going to examine again the residual plots. We don't see any clumping, we don't see any trends, we don't see any patterns. So we're going to make the determination that our independence assumption was met. Next, we're going to look at the equal of variance assumption, which is also known as equal spread, and we want to see that the variability of y is about the same for all values of x. So we're checking the scatter plot of the residuals against the age x, and we see that the spread appears fairly constant everywhere. So we're going to determine that the equal variance assumption has been met. And finally, we're going to look at our normal population assumption. And our normal population assumption wants to assure that the residuals follow a normal model. And we know this is important because it is required to use the student's t-model unless the sample size is large. So we're going to look at a normal probability plot of the residuals or a histogram, and we'll actually do both of those. We're going to do that in StatCrunch. So I'm going to copy our data and go into StatCrunch. So here we are in StatCrunch. Let's open StatCrunch, and I'm going to paste our data in, Control V as in Victor, and there it appears on the screen. We go Stat, Regression, Simple Linear. Okay, X variable we know is age, Y variable, prices advertised. So under graphs, fitted line plot, pressure control key, histogram of residuals, QQ plot, that's our normal probability. And we'll go down and we'll take a look at our predicted values versus residuals. You can also do residuals versus X values. We want to save our residuals and our predicted values. And we will press compute. And I will move this screen up so you can see this. Here is our regression results. You will see that you have your regression equation in the output, which is very handy. You have your intercept, same intercept, the 12,139, and our slope of -842. We also up here, the residuals are populated out and the predicted values. Now, if you look down to the lower right, there's an arrow. There is your scatter plot of your prices versus age, and you can copy that into Excel or onto your worksheet. Here is your histogram of residuals. You can see that it is relatively symmetric, so we'll go nearly normal. Here's your QQ plot, which is your normal probability plot. Against, see your residuals here on your y-axis. We can see it's fairly straight. Not too much, a little bit of variation here, but relatively straight. So that looks good as well, even though there's a little bit here. And we will go to our predicted values versus our residuals. We compared our X value versus our residual, but you can see here very little pattern. So we could use this as opposed to comparing the X value, the age, to the residuals. It was just generated in our regression analysis in Excel, so we did that. So it looks like all of our assumptions and conditions have been met. So we can see that we have created a scatter plot, and we determined that a linear model was appropriate. We found the equation of the regression line, and then we determined that the residuals for the assumptions and conditions for inference had been met, as we discussed. So that is the way we solve problem 6. If you have any questions, please do not hesitate to reach out to your tutors and your professors. We are here to help you, and we hope you have a great week.